we're going to take a look at a famous physics problem. This is the monkey gun problem, and the story goes like this. There's a monkey hanging out in a tree, and he's just minding his own business, trying to avoid being hunted or shot at or whatever. So he's like, here I am hanging out in this little tree. I'm a monkey, hanging upside down, don't know why. Anyways, there's a hunter over here some distance away, or a zookeeper or whatever, and he sees the monkey and he says, oh, I need to capture that monkey. So I'm going to aim my tranquilizer dart in the monkey's direction and I'm going to shoot at my monkey. But as soon as he shoots, the monkey's like, whoa, I got to get out of here, and falls. And what we want to know is, what happens to the monkey besides, falling? Does he get hit by the dart? So here's the information. A zookeeper's trying to catch a monkey. He spots a monkey hanging in a tree 40 meters away from him. So I know the range that this thing has to go is 40 meters. The monkey's hanging 15 meters above his head. So this distance that the monkey is above the shot is 15 meters. The dart travels at 60 meters per second. So this velocity that it leaves the gun with is 60 meters per second. Okay? And we know he aimed directly at the monkey. So we want to know, does he hit the monkey? Well, let's see. I need to know a little bit more information, but I think we can figure this out. I want to know this angle. I want to know the angle he shot at. Well, if I look at my triangle, I have two things I can use. I don't want to mix measurements. The 60 meters per second is not the hypotenuse of my distance triangle, right? I know the monkey is 40 meters away and 15 meters up. So whatever angle this is the angle of my velocity triangle. So I'm going to use tangent. I'm going to use arctangent. The arctangent of 15 divided by 40 is 20.55 or 20.56 degrees. So theta equals 20.56 degrees. Okay? So that means I can figure out the horizontal and vertical components of velocity. So the dart is separate from the monkey, so I'm going to keep the dart separate. So over here I know the initial velocity in the x direction of the dart is 60 times the cosine of my 20.56 degrees. So I'm going to go ahead and do that. 60 times the cosine of that is 56.18 meters per second. Okay. The initial velocity in the y direction of my dart is 60 times the sine of 20.56 because it's the opposite side of that triangle. So 60 sine 20.56. That gives me 21 meters per second. Alright, so I want to know, is he going to hit the monkey? Well, as soon as he shoots, the monkey starts to fall. So we've got to figure out where the monkey is. So the monkey's over here, and I know a little bit of information about him. The monkey has an initial velocity of 0 and an acceleration in y of negative 9.8 meters per second. Gravity pulls him down. And he starts, his initial position is 15 meters. Over here, the dart, its initial position is 0 meters. So let's figure out how long it takes the dart to get to where the monkey is. So that's the x position. Delta x equals v naught t. So his initial velocity in x is 56.18 meters per second. Okay? And times time, whatever it is, has to equal the 40 meters that this monkey is away. So I'm going to take 40 divided by 56.18, and I see a time of 0.712 seconds. So t equals 0.712 seconds. Now, how high is the dart at this time? Or where's the monkey at this time? If they're in the same spot, then the monkey gets hit. So if we come over to the monkey, I want to know where he's at. So y equals 1/2 at squared plus v naught t plus y naught. So where's the monkey? Well, y equals negative 4.9, half of 9.8. T, which is 0.712 squared, plus his initial velocity is 0, plus his initial position. Remember, the monkey started 15 meters up in the tree. So 4.9, negative 4.9 times 0.712 squared is negative 2.48. And plus 15 gets us our final position of 12.52. Okay. So the monkey is 12.52 meters off the ground, or off our 0 point, when the dart reaches the monkey's vertical position. Is the dart going to hit the monkey? Well, for to answer that question, we've got to go to the y direction in the dart. Okay, so we know the initial position for the dart was 0. We want to know the final position. And we know the initial velocity in the y direction for the dart was 21 meters per second. We know the acceleration in the y direction is negative 9.8. So if we use what we know, y equals 1/2 at squared plus v naught t plus y naught. We see that y equals negative 4.9 t squared plus 21t plus 0. And remember, our time is the time it takes for the dart to get to where the monkey's at, 0.712 seconds. So this equals negative 4.9 times 0.712 squared plus 21 times 0.712. And if we do that math, negative 4.9 times 0.712 squared plus 21 times 0.712, we come up with a position of 12.47 meters. Okay, so the dart is 12.47 meters off the ground, the monkey's 12.5 meters off the ground. Yes, the hunter hits the monkey, or the zookeeper hits the monkey. Okay, and the reason, if you think about it, is because as soon as the dart leaves the gun, it starts to be in free fall, so it's going to come down. Okay, if there was no gravity, the dart would have gone directly straight to where the monkey was, and if there was no gravity, when the monkey let go, he'd still be there. So those two things would be in the same spot. Since gravity acts on them both the same, it pulls the dart down, it pulls the monkey down, and he still hits. So the monkey would have been better off holding on to the branch. And if he had, then the shooter over here would have had to aim up here somewhere so that the dart, when it started to fall down, would actually hit its target.